Hi all, good morning. I hope you're doing well. I'm going to make a quick video to help you with your algebra lesson for this week. So starting with your cool down, you're going to be picking a growth factor for your exponential equation for COVID and then justifying it. So on your day 4 lesson, if you're modeling COVID, you're going to open up that document, and I'm just going to read through some of these arguments and then think about which one I want to use for my cool down. So to compare the first two, obviously the growth rate of 1.27 is greater. It's growing at 27% compared to the growth factor of 1.11. Doubling every 7 days versus doubling every 3 days. The difference between these two is the 1.27 uses US data, so just data from this country, and it only uses US data from the last week. Over here, the 1.11, that's data from the whole world, and it's also since the start of the virus. So like the starting time is different and the location is different, the whole world versus just the US. Let me read through the other two as well. So this one's huge. This is a growth factor is 1.4. That would be about 40%. And that would mean the spread of the virus is doubling every 1 to 2 days. So just think about that for a second. That's crazy. That means pretty much every day, twice as many people would be sick as the day before. So that would be wild. Right now in the US, there are about 1,000 confirmed cases. That would mean tomorrow there would be 2,000 confirmed cases. That's a huge growth rate. And the argument for this one is that we're not testing everybody, so basing our estimates on confirmed cases ignores all the people who have the virus but who haven't been tested. So people who haven't been officially confirmed as having coronavirus, but they might have it. They just haven't had a chance to get a test. Ooh, that would be really scary. The last one is 1.15. So it's kind of between the first two. And it says people are starting to take the virus more seriously and governments are putting in more policies for social distancing and staying at home. If we want to predict the future, we should assume that the spread of the virus will slow down compared to the past week because those policies and social distancing measures will keep the virus from spreading as quickly. So this last one is an interesting one to me because it's kind of in between the first two. It's like this one is saying this is what's happening in the whole world on a longer time scale. This one's like what's happening in the US just over the past week. And this one is like, okay, it's going to be somewhere between that. We'll eventually get to some place where we're kind of in between the worldwide growth rate and the US growth rate. That makes more sense to me. For me, I'm automatically eliminating the yellow one because that's just like super extreme. That would be really, really, really high growth rate. That seems too much. And the green seems for me to be a good guess because it's like in between the two extremes of the purple and the blue. Okay, so I just talked this through. It probably will make more sense once I actually write out my reasoning. So I said I was going to pick the 1.15. And let me quickly model for you why I picked that growth factor. So I think that the value of 1.15 is most reasonable as a growth factor for my model because, let me think about what I was saying. So saying because it is in between, what were the other two? 1.11 and 1.27, both of which rely on reasonable assumptions. So let's say the growth factor of 1.11 is the long-term growth rate of worldwide cases, and the growth factor of 1.27 is the growth of cases in the US in the past week. I am assuming that the growth factor will end up being between these two numbers, that that social distancing will slow down the spread of the virus, but also there are many cases that still have gone untested, so the numbers may actually be larger than we think. Okay, so basically I picked the number that was in between the lowest and the highest because I think both things are true. I think social distancing is slowing down the virus, but at the same time, there might be more cases than we even know. So I'm choosing kind of like a balanced argument that's halfway between the two extreme numbers. Okay, I think my argument's pretty strong. And that is the model of today's lesson. After this, you're just going to take a quick survey. Hope this helped you if you're writing this cool down for the day. And make sure you keep reaching out if you need any help. Stay safe. I hope you're doing well. Thank you for watching this.